My name is Gihan Chandrathilake from the International School of Urban Science at University of Seoul. It is my privilege to present my research analyzing the relationship between population distribution and land areas in Sri Lanka's western province. Thanks for your time. Content. To guide our discussion, I will first provide the background and context of the study, followed by the description of our research problem and its significance. I will then detail our methodology, present our key findings and analysis, and conclude with our main conclusion and the recommendation for the future works. Background of the study. Understanding the spatial dynamic between where people live and the land they occupy is absolutely vital for effective urban planning and the sustainable development. In Sri Lanka, the western province, comprising Colombo, Gampa and Kaluthur, is a prime example of rapid urbanization leading to urban sprawl, infrastructure congestion and environmental stress. Our study zeroes in on this region, examining the correlation between population and the land at the granular division secretariat division level, using Pearson correlation and the GIS to assess demographic pressure and the spatial inequality. Study area. The western province is Sri Lanka's most urbanized, densely populated and the key socio-economic hub. Our analysis cover 40 division secretariat division or DSDS. As you can see on the map, these include area from the highly urbanized Kadwela to more rural part of the Kaluthara. This variation provides an ideal urban-rural continuum to explore the critical disparities between land availability and the population concentration. Research problem. The core issue we address is the uneven urban development within the province. Colombo metropolitan region has advanced rapidly while peripheral areas have remained relatively underdeveloped. This has created significant imbalance in how population is distributed relative to the land. Furthermore, previous studies have rarely examined that statics and the spatial correlationship between these two variables at this detailed DSD level. Our research aims to fill this gap. Significance of the study. So, why this is important? Our study provided an empirical examination of the population-land relationship by unequally integrating statistical analysis with GIS-based visualization. This combined approach reveals patterns that pure statistical or maps alone might miss. The findings are designed to support data-driven policymaking by identifying spatial inequalities which can guide more balanced development and improve resource allocation for sustainable and equitable growth. Methodology. Our methodology was carefully designed for robustness. We select DSD as our unit of analysis because it offers consistent, granular, and comparable spatial framework. The data come from authoritative national sources, population and land area figures from the Department of Census and Statistics, and spatial boundaries from the Survey Department. All data sets were projected using Sri Lanka National Grid to ensure accuracy of the GIS analysis. Analytical method and spatial visualization. Our analysis was twofold. First, we used Pearson correlation coefficient to quantify the strength and the direction of the linear relationship between the land area and the population size. Second, we used GIS to create a thematic map visualizing population distribution, density over time, and land use. This powerful combination allows us to not just calculate the correlation numbers, but to see the spatial expression across the province, providing much richer understanding. Finding analysis. Let's now move our finding and analysis. We will first provide an overview of the spatial and temporal patterns of population and the land use, and then delve into the specific statistical correlation and uncovered. In here, you can see the population distribution from 2002 to 2020 and population density in 2020 at the region. Overview of land area, population and population density. First, looking at the spatial concentration. It is immediately clear the population is not evenly distributed. It is heavily concentrated along the western coastal and central urban belts. Colombo, Gampaha and peri-urban areas of Kaluthara show the highest density and have experienced continued growth. When we experience the temporal trends from 2002 to 2012 to 2020, Our maps reveal a story of progressive intensification. Population density have constantly increased, a trend driven by the both natural population growth and significant rural to urban migration. This lead to distinctive spatial pattern. We see extremely high density of 6,000 to 8,900 person per square kilometers in the Colombo metro area and its immediately surroundings. Medium density in peri-urban fringe of Gampaha and Kalutara, and low density of less than 1,300 person per square kilometer in the inland of southern division, which are characterized by more agricultural land use. The land use distribution map of 2020 confirm it these patterns. Built up areas dominates the western coastal zone, while agriculture and forest land persist inland, though they are become increasing fragmented. From statistical interpretation, the visual pattern strongly suggests the negative correlation, meaning smaller DSDs are associated with the higher population concentration. This confirms the presence of the significant of urban-rural imbalance. The planning implications are direct. This data highlight the urgent need of spatially balanced growth, target infrastructure investment, and sustainable land use planning to manage this intense concentration. Correlation, interpretation, and initial result. This brings us to the crucial statistical test of what we observe on the map. We use Pearson correlation coefficient to move the visual pattern of quantitative relationship. As a quick reminder of how interpretation Pearsons are, an R of plus 1 indicate the perfect positive correlation, and R of minus 1 indicate a perfect negative correlation, and R of 0 means no correlation at all. Now we are our key result in the Western province of 2020. We found the Pearson's R minus 0.242. This indicates a weak negative correlation. Furthermore, the p-value is 0.167, which is greater than the standard threshold of 0.5. This means that this weak relationship we observe is not statistically significant. So what does this initial result tell us? First, larger land area show only a slightly tendency of the have smaller populations. Second, this relationship is too weak to be predictive. And this leads us to the critical conclusion. Population distribution here is influenced far more by other factors like urbanization, infrastructure, and economic activities than by the physical land area alone. Correlation, regression, and deeper insight. This delves deeper into this correlation. We can express this relationship as a regression equation. The equation we deliver is population equal to minus 293.93 by area plus 190,040.54. In practical terms, this model suggests that for each additional square kilometers of land, a DSD has approximately 294 fewer people. The negative coefficient solidifies that a weak negative relationship we found. However, we must again emphasize that this model is not statistically significant. Land area alone simply does not explain the variation in population. This becomes a clear district level insight. Colombo district has a small area but the highest population, driven entirely by the powerful economic and administrative role. In contrast, Gampaha and Kalutara have much larger land area but only moderate population. This highlights that the influence of urbanization and infrastructure overweight that influence of the disease size. Therefore, our finding confirm the existence of complex spatial demographic relationship what cannot be captured by a single variable. This clearly suggests the need of future studies for employee multivariate analysis in comparative socio-economic, and infrastructure variables to build a more accurate and exploratory model. Conclusion and recommendation. Our conclusion, our study focused a weak, statistically insufficient negative correlation between land area and population in the Western Province. The key takeaway is the land area alone is a poor predictor of population distribution. Instead, correlation is driven by economic centrality, historic development, and infrastructure. Therefore, our recommendations are to move beyond the one dimensional planning. We must implement multidimensional strategies that integrate infrastructure, economic factors, and the land use zoning, prioritizing high density center while enhancing peri-urban area and rural connectivity. Resource should be allocated based on the demographic pressure, and we must strengthen institutional capacity for evidence-based collaborative planning. Future direction. For future research, we propose several exciting directions. First, to improve longitudinal data and the socio-economic variables like income and employment for deeper for dynamic understanding. Second, to employ advanced spatial econometric and the remote sensing method to capture non-linear patterns. Third, to extend this analysis to other provinces to or a South Asian context to comparative insight. And finally, to integrated stakeholder input to ensure that our research remain connected to local realities and the strength to evidence base for integrated planning. References. Our research stands on the shoulders of the giants, and we are grateful for the works of these scholars and institutions. Including the Department of Census and Statistics, Sri Lanka, was data made of this study possible. This brings me to the end of my presentation. I extend my sincere thanks to the conference organizers and my colleagues. Thank you for your kind attention.